today's focus will be on the Doppler effect. Okay, so everybody's heard of an ambulance or a fire truck that comes towards you and then it goes away from you, and you notice that it actually has a different sound to it. And if you closed your eyes and you were making the observations through your sound, you could tell actually if the fire truck was coming towards you or going away from you based off of that sound. And what that's known as is actually the Doppler effect. The Doppler effect is a change in a wave's apparent wavelength, so what it seems to you, and frequency from the observer's perspective. Okay, it's not actually changing its wavelength and frequency. Like if I was on that truck making the sirens go off, I wouldn't notice any difference in sound. But the person who is standing outside of the truck and it's either coming towards them or away from them would. So it's all based off that observer's perspective. All right, an object moving towards an observer. So what we're going to do is we're going to show it, and what happens is it bunches off. Okay, so if this is your little siren, okay, and these are the sound waves that each blue ring represents a sound wave, right? So this is the sound wave that it's releasing. So and each one represents one of these rings, okay? Now we're going to be moving that source. So notice this is standing still. Each distance between the waves are the same, right? Now we're going to be moving this. So in itself, we'll be releasing this exact same circle each time. But because it is moving towards that way, what do you notice about this area of those sound waves? Well, they're bunching up, okay? Which means that this guy looks more bunched up than this guy, which actually, if you look at it, is spreading out. So as it goes towards you, if I was an observer here, it is bunching up. And if I was an observer here and it's going, I'm going to erase that, and I'm an observer here, what is this? And listening to this guy, it looks like it's spreading out, which means that the wavelength and frequency, the wavelength is getting longer and the frequency is getting less. When it is going towards you, it looks like the wavelength is getting shorter and the frequency is getting more. Okay, so it's an apparent change. It actually is constantly releasing this, but because it's moving, we observe either this guy or this guy, depending on whether it's coming towards us or going away from us. All right, so away from us, if you look at it, this is once again just another visual. It's releasing, the siren is releasing this constant little circle, but because it is moving towards this guy over here, it bunches up its frequency. Okay, so it's a higher frequency, smaller wavelength. It sounds higher pitched. This guy over here, where it's going away from this observer, it is experiencing a longer wavelength and a lower frequency. All right, so the Doppler effect, once again, what it does is it's a shortening of the wavelength if it's coming towards you and an increasing of the frequency. And if it's going away from you, it is making the wavelength longer and it is decreasing the frequency, making a lower pitch. So this would be a lower pitch and this is a higher pitch. So if I want to experience the Doppler effect, I can change, it's an apparent change in both its frequency and its wavelength. All right, so let's try to draw two pictures, a source at rest and the sound is at rest. So the source is not moving and the sound is not moving towards or away from an observer. Okay, so try to visualize what that would look like. Would you notice any difference if I was standing still and a fire truck was standing still? Would I notice any difference in its pitch, meaning its frequency and its wavelength? No, I would not. It would be the exact same. So if I observed this, I would notice no difference. It would be a constant monotone, right? Okay, now the picture 2, source of the sound is moving towards the observer. Okay, the observer is standing still and the source, so the ambulance, is coming closer to that. So would you notice a difference in that sound if you were standing still and a fire truck was coming towards you? From your experience, I hope that you would experience that it would be some sort of change. And what's going to happen is it's coming towards you. Those sound waves are going to bunch up, which means you are going to have a shorter wavelength and a higher frequency. So it would look like this. Okay, so this is your observer. Notice that it is shorter wavelengths and more frequent. Hopefully you guys understand a little bit about Doppler effect, and you have a great day.